Hello everyone, welcome to the P4 workshop. I'm Arun Paneri, working as a Director of Product Management at NoviFlow. Today I'm going to present about our latest initiative, that is P4 based NoviSpeaker, and that's going to be released in the market at the end of this month. The main purpose of this presentation is to launch a technical insight of this fantastic product that sits on top of the SDN switches and serve the purpose of the P4 runtime controller. And then one of my colleagues, Jeff Alpern, will briefly talk about P4 runtime based SDN application products. Those were built on top of NoviWare SDN NOS and NoviSpeaker SDN controller. This is the agenda. I'll talk briefly about the company, and then we'll take a look at the NoviFlow software stack, NoviSpeaker's advantages, why we build this NoviSpeaker, its architecture in detail, and then Jeff's part, which will cover this SDN application products. Okay, let's jump into this history of brief history of NoviFlow. So NoviFlow was founded in mid-2012. Company's headquarters is in Montreal, and we have multiple offices in the US, like one is in the Bay Area, Seattle, and a couple of offices around Boston in the East Coast, and in the other part of the world as well, though mostly those are sales offices, like one we have in Singapore and another one in Australia also. In 2012, we started on the concept of programmable match action pipeline and launched OpenFlow-based NoviWare NOS that is compliant with OpenFlow specs 1.3, 1.4, 1.5. Those specifications were built on top of our NPU-based hardware. So there were multiple different switches available for NPUs, though still we sell some of those switches actually. Those were somewhere around 400 gig switches, and both NoviWare and NoviSwitch products were deployed in many tier 1 carrier as well as in the enterprise networks all around the world. Later in 2016, we moved to the P4 technology and launched our P4 runtime-based NoviWare version for Tofino-based white box switches. And in the same year, we moved up in the ladder and launched many different P4-based SDN applications also. So in the last 4 years, we built so many applications on top of this Tofino-based hardware, and we have still been selling those solutions. Jeff, as I said, Jeff is going to briefly talk about those applications later in this presentation. But NoviFlow is primarily a software company, and our business model is based on software licensing and system sales. Okay, now let's recap this SDN architecture. You guys might have seen this particular picture so many times, but I'd just like to go again through it and see how NoviFlow fits in there. So most of the deployment of network solutions are more often based on closed platforms that come with their own protocols and CLIs or other control plane proprietary interfaces and tools provided by the NOS vendors, right? And those are primarily traditional networks. However, a P4 initiative were taken in the direction to provide a way to customize these hardware devices where service providers, data center carrier, system integrator, or researchers can modify and optimize different forwarding planes, pipelines as per their need. So they need not to always depend and rely on the hardware vendors to release some of the features which are required for their need actually. So if you look at the traditional network stack, then there's a forwarding plane which is mostly based on ASIC or FPGA and comes from these hardware vendors, right? And then the NOS on top of that, and then the control plane application that talk to the NOS and forwarding plane through some proprietary protocols, right? So that's every time you see those kind of networks, they are based on these proprietary protocols. But on the other hand, if you look at the SDN network stack, then there is a programmable forwarding plane. And Tofino is a really good example of this programmable ASIC. Tofino is a chip from Intel Barefoot, and it's a fully programmable chip. Then on top of this network infrastructure layer, there is the control layer, right? And you require a NOS that supports open networking specifications like P4 Runtime to support a control plane that's provided by a programmable controller, right? On top of that, there are applications that control and control the underneath data plane network infrastructure. So all these the protocols and interfaces are completely based on the open networking in SDN architecture. NoviSpeaker actually belongs to the control plane part of this stack, and so this presentation will more concentrate on the control plane and its north and southbound interfaces. So if you see NoviFlow, then you'll find like we have a products at every level of this SDN stack. We have this NoviWare, which is P4 runtime based network operating system. That's at the data plane or infrastructure layer. And then we have this NoviSpeaker, which is kind of a P4 based controller actually, which it plays the role of the controller actually. And it sits at the control plane, of course. And then we have different SDN applications at the application layer, like CyberMapper and visual latency. Okay, now before we get into the technical details of NoviSpeaker, I would like to talk a little bit about what sort of problem NoviSpeaker is trying to solve and how it's actually beneficial to the system integrators and service providers and developers of the control plane pipelines and applications. So we all know that the networks of carriers, data centers, and enterprise are always very complex, and to control these hundreds of different devices in the network, one needs to have a robust control plane software. And to get the robustness and efficiency of this control plane software, this software becomes equally complex, right? And hence, there's always a need of some sort of centralized control plane platform to manage the forwarding plane systems in the network. So writing these software and maintaining these control plane software is always time consuming and requires highly efficient manpower. So in the P4 programming world, there's no commercially managed control plane software or controller currently available, and NoviSpeaker fills that gap in the P4 ecosystem. NoviSpeaker provides competitive advantage to the users to bring their application products to the market fast and in a timely manner. P4 application programmers need not to worry about developing the spatial frameworks as part of every P4 program and application, because NoviSpeaker provides that framework and brings the programmers on board to directly start writing the P4 program and applications without worrying about the paraphernalia required to start writing those control plane applications. Moreover, it's a highly efficient and robust software that provides cost savings for application development, also cost savings in debugging the applications, and runtime pipeline issues, especially in the switch, in the network. If we talk about some technical advantages, then NoviSpeaker helps P4 programmers in writing programs that uses Tofino switch resources more efficiently, like the parsers, the metadata, SRAM, DRAM, and other chip resources are efficiently used when you involve NoviSpeaker as part of your software infrastructure. It also provides high visibility of running pipeline at the runtime. That is very helpful feature, especially for debugging of the pipeline and applications. And because it helps supporting multiple Protobuf files in our NoviSpeaker P4 based NOS, and we have like support of these multiple protobuf files, P4 or BF protobuf files, or our proprietary protobuf files. It actually supports many features. Those are not part of the P4 runtime specification because of this proprietary protobuf file, and I'll briefly talk about it later in this presentation. Okay, now let's look at the SDN infrastructure again from the P4 or barefoot runtime point of view. Tofino supports a programmable data plane, meaning that using a P4 or BF runtime, users can replace the pipeline in the Tofino as per their business requirement of the network. And NoviSpeaker provides a mechanism to compile the P4 program and push it into the Tofino over P4 runtime protocol. NoviSpeaker is actually a client that connects to the switch and maintain that connections throughout the life of the switch actually. It provides the northbound connection for business applications and southbound to control the switch at the runtime. So basically, from the state machine wise, if we see the switch first boots, then NoviSpeaker connects to the switch. Then NoviSpeaker compiles the P4 program and pushes it into the pipeline, into the Tofino. Then connects to the applications on the northbound side, and then maintain these connections with the switch and the business application to control the network basically. There are few other interfaces available between switch and the NoviSpeaker. But P4 runtime is the main interface that is used by the NoviSpeaker actually. Okay, let's look at the architecture of the NoviSpeaker. So let's start from the bottom and go up in this picture to understand the architecture of NoviSpeaker. So there is a Novi gRPC client connection management layer at the bottom, right? That basically manages the secure southbound interfaces, and those are primarily gRPC, GNMI, GNOI, and P4 runtime. That layer provides support of either BF or P4 runtime protobuf file along with Novi protobuf file, and it's really amazing to see that NoviSpeaker supports two different protobuf files at the same time. One is standard P4 or BF protobuf, and another one is a proprietary protobuf file from NoviFlow. The purpose of having a proprietary protobuf is that there are quite a few interesting features that should be covered by the RPCs in standard protobufs, and unfortunately they are not yet available neither in P4 runtime protobuf or in BF runtime protobufs. Though BF runtime protobuf, I would say it's a superset of P4 runtime protobuf. So those missing features can easily be supported by using the RPCs from our proprietary protobuf file. We release this protobuf file to our customers along with the release of NoviSpeaker, and same corresponding protobuf file is available in NoviSpeaker NOS also. Of course, you require a corresponding protobuf file at the gRPC server level also, right? So this proto is used in gRPC client, which is NoviSpeaker, as well as in the gRPC server that is part of the NoviSpeaker NOS running in the Tofino. So when we release a speaker, and if we have to do changes in the NoviSpeaker, the P4 proprietary protobuf file from the NoviFlow, then we have to upgrade NoviSpeaker NOS site protobuf file also. There is another protobuf file we use for the northbound interface on top of the NoviSpeaker that manages the interface between the business applications and the NoviSpeaker, and I'll talk about it later in this presentation. Okay, so on top of this connection management layer, there is a P4 middle layer, and that basically translates all the information in the format north and southbound interfaces understand. Next, there are some cool fancy features in this product, like support of the async messages, port mapping, logs and CLIs. Many of the async message support is not part of this P4 runtime spec, and we provide that support through NoviSpeaker using again our Protobuf's proprietary Protobuf file. We also have a feature called port mapping that translates those P4 port entities from those 64-bit hardware IDs to the front panel port numbers, because that's really handy to see the front panel port numbers in the logs, and even while writing the application, you really need, if you mention the front panel port numbers instead of those hardware IDs, then it's really easy to program or write the application programs. In the flow entry also, or in the output of these flow entries, or even in the packet ins, let's say if you look at the packet ins, if you see those 64-bit long numbers instead of the front panel port numbers from where packet ins are arriving, then that would be very confusing. But NoviSpeaker maps those Tofino entities or port hardware IDs into the front panel numbers. Now, on top of the NoviSpeaker, user will write this control plane application that will interact with the switch at the runtime. And imagine that application user needs to keep track of these Tofino entities in the application instead of the corresponding human readable names, right, of those entities. Then it will be really very confusing and time consuming also for application developers or system admins who are debugging the pipeline and applications at the runtime. And similarly, there is a mapping or translating module in NoviSpeaker that maps all the different these Tofino entities like table IDs, match fields, and actions into a human readable format for application developers and for the runtime debugging. I mean, this is a really cool and fancy feature there. So imagine the struggle developers and users of control plane application may have to go through without having this NoviSpeaker handy for the application development and debugging. Next, we see this in this layer, the layer of northbound interfaces, where control plane applications are connected to the other end of the NoviSpeaker. Currently, we support only gRPC interface, and we have plans to support REST in the next release, and JSON in the one after, actually. And as I explained earlier, there is a module in the NoviSpeaker that takes care of compiling the P4 pipeline program and push it into the Tofino chip. From this picture, architecture of the NoviSpeaker looks quite simple, but we have put a lot of intelligence in this product. Here I'm not showing you everything we have in this product, like just for an example, like there is a complex design of a configuration manager that keeps track of configuration changes done by the application at the runtime in the pipeline or in the switch, and also store a running configuration of the switch in the database, and keep that database in sync with the running switch, right? So it's highly complex module there. We also have CLI support in this NoviSpeaker, where user can log in and check the status or logs of the NoviSpeaker especially for the debugging purposes. Okay, next, these are some of the features of NoviSpeaker I have listed here. We talked about the connection management, how NoviSpeaker provides gRPC, GNMI, GNOI, and barefoot or P4 runtime connection towards the switch. We also talked about having support of multiple protobufs, and we also have support of extern. Extern is like in P4, it's like what experimenter is in OpenFlow actually. So through extern, we have provided some of the features. Those are neither part of the P4 runtime nor part of the barefoot runtime, like multicast group support, lag, session mirroring support, etc. And another fancy feature is a rollback on error. Even though P4 program compiles, there could be an issue with those can occur at the runtime, right? So runtime issues could be there in the program. If NoviSpeaker identifies, so when you push the P4 binaries into the NoviSpeaker actually pushes the binary into the switch. So before doing that, NoviSpeaker tries to identify those runtime errors or those kind of issues in the P4 program. And then if it doesn't push the binaries in the Tofino, if it finds those errors, and also warn the user by displaying an error. So if you see if NoviSpeaker doesn't push new pipeline into the Tofino, then Tofino continues running the old pipeline. So there is no disruption in the data plane also. So packets processing is continuing while NoviSpeaker tries to do all this. And of course, it also supports the live swapping of the P4 program. That is called a fast refresh. Okay, let's move to the next slide, which is more about this Protobuf file for the northbound interface of NoviSpeaker. So I would like to talk a little bit about this northbound gRPC interface and how we use this Protobuf file. So once the NoviSpeaker connects with the switch, it fetches some information about the switch through this receive switch info, right? Like DPID of the switch and other information, especially about the ports, because different hardware form factors are available, right, from the front panel point of view. So we use these Acton H-core Tofino based wedge 100 switches, and one of the switches having a 32 ports, whereas another switch is having 64 ports on the front panel. So when NoviSpeaker connects to the switch and try to receive the information, it gets all these sort of information about the underneath hardware. And then once the P4 code is ready to compile, then user call these compile P4 code kind of APIs to compile the P4 code, and then P4 binaries are pushed into the Tofino. It also registered application, northbound application, through the register application gRPC message. These RPCs of northbound protobufs are pretty handy for the application developers, and they are very easy to use. We provide all the detail about this protobufs, as well as we help customers to understand these protobuf RPCs and how to use them actually. We also have a training related to this P4 speaker. If you guys are interested, you should contact us for that as well. Okay, so next, NoviSpeaker is a containerized distribution that makes it very easy to install, and it works only with Tofino based switches, though those are running the NoviWare runtime NOS. So you must have to have a Tofino switch which is running a NoviWare NOS to connect to this NoviSpeaker basically, or to use the NoviSpeaker. For the redundancy purposes, NoviSpeaker has a support of primary and backup NoviSpeakers, and can connect to the multiple switches. So every instance of this NoviSpeaker can connect to the multiple switches, including the Tofino simulator basically. Okay, and of course all these different instances of NoviSpeaker can be run on a single server that serves as a SDN controller. All right, what next? So I would like to just briefly give you an idea how people use this NoviSpeaker in the lab and then move it towards the deployment. So NoviSpeaker can also be used with the Tofino simulator, running NoviWare SDN NOS, and we call them like SM5000 simulator. So we provide a virtual machine that that has this simulator for Tofino, as well as it runs our NOS NoviWare. That way, customers can design, develop, and test their P4 programs and applications using the simulator, and then deploy them on Tofino-based hardware. It's really a cost-effective way of doing application development, and especially the lab trials, right, of the P4 pipeline and applications. Migration to NoviSpeaker is also quite straightforward and very graceful, especially if you are already running a NoviWare in your Tofino-based switches. Then you need not to even compile your P4 program that was previously compiled for the Tofino-based architecture, and also switch need not to be rebooted once you push those. Push the new pipeline. I think that's all I have for the NoviSpeaker part. More detail can be found at noviflow.com, and if you would like to see the demo of NoviSpeaker, then feel free to contact us at contact@noviflow.com. With this, I hand over to Jeff, who will talk about some of our application products built on top of NoviWare SDN NOS and Speaker. Jeff, over to you.
Hi, I'm Jeff Velpern, a project manager at NoviFlow, specifically around applications, and this is going to be a short testimonial of how powerful the NoviWare and NoviSpeaker components are as a strategy for implementing SDN out there. And it's going to be from the viewpoint of us as a heavy user using these technologies to launch products into the application space. So it'll go across kind of an outline here. I've got 4 applications that I'll talk about, mostly from what did we do in the pipeline? What were the innovations in the pipeline? And then we'll have a sneak preview of our next big project coming out. It should be really fun. We'll try and line this up with how the silicon algorithms were crafted by the developers, give you a little insight if I can, talk consistently about the time to market and how this shortens that, and how leverage it is that an application developer like us with as few engineers as we have can cross this many segments is just unbelievable. And then hit home that all of these things are terabit throughput out there across the load balancing, mitigation, traffic steering, very, very high performance environments. So our first product that we moved out as we realized we had a very powerful tool, and we thought it could be used better and more powerfully in some segments than it had, was around very high performance load balancing and security mitigation out there in the security infrastructure. We got an insight when I partitioned the market into stateful and stateless, and realized that most of the stuff was really stateless load balancing that needed to be done, and that we could bring an algorithm to bear on that could do that at terabit speeds. So this product has, as you can see on the left-hand side, all the features of a big-time load balancer out there, but its key thing is it's running at terabit speeds, very, very high speeds, and very, very good solution for being on the data plane for somewhere, with high volumes like in the telco industry, where we're dealing with really, really high throughput. So the big breakthrough, like I said, was that in the pipeline, when we created what we called enumerated hash, we were able to use the Tofino technology to take a big stream, divide it into a set of little streams, and then pin those to firewalls, in a load balancing algorithm that made it not only powerful but very high failover, didn't move flows when it failed out there. Just a sensational new breakthrough in price performance in this area, and it served us very, very well. The next thing we did then was look at extending that. We realized that there were more things we could do around this and then load balancing and mitigation, in that pipeline. And very specifically, we started talking about how do we add regular packet broker services to the CyberMapper in addition to just the load balancing. And there we came up with whitelist and blacklist. How could we, move packets around, through the system much faster if they didn't, they weren't high risk, if they didn't need to be processed over by security tools. How could we put steer some traffic to passive offline tools, as a tap, things like that. Again, using the internals of the P4 pipeline, having access to those through the NoviSpeaker at a very high level that just kept us always concentrated on our code, nothing on how do we communicate with a switch. All of that was taken care of for us. So, we cranked this out in a very short period of time and a bunch of sensational features. So, proof point number 2. Next, the carriers that we worked with came back and said, we really like that, but, we have a lot of, carrier grade NAT going on where the address on the internal, mobile side for the subscriber is different than when their packets move out on the internet. And we go through this translation out there. So we looked at it and said, all right, on the inside, we can use the algorithm we have, the load balancing algorithm we have. But when we go out to the network, we're going to have to invent something more. And we noodled on it for quite a while. And then we came back and said, okay, this is just a packet steering problem. We know at the CGNAT walls what public IP addresses have been applied to them. We can map those as they come back, get it back to that exact same. In this case, our partner for it was Fortinet. We can get that back to the exact same Fortinet device that natted it. It will know all the details about doing that. And on the left-hand side of this equation down here, where you see we already know how to load balance. So this one was, again, another proof point of how incrementally we were improving the product, but all of it is just really based on SDN and the delivery of P4 and NoviSpeaker to give us control of the silicon at a high level where we can innovate at the application space and not have to worry about all the internal stuff. So the next one we added here is kind of interesting because it isn't a main, what you would normally look at for a switch. One of the things we saw was that the packets, going through these tools, as you added rules or they became, loaded, could start to add a lot of latency. And so the question was, okay, well, how can we measure that? How can we deal with that and provide feedback to our customers about, what's happening in their tool sets? And to do this, we used the new INT headers for, telemetry out there, and a very innovative process where coming into our algorithm, we insert an INT header, we timestamp it, we send it off to a security tool. When it comes back, we timestamp it again. If it goes to another one, we do the same process. And then when it finally gets back to us, after all the service changing to the tools, we pop that INT header off of it and send it downstream pristine. So it looks just like it came in. It's gone through the security tools. But we take that INT information and send it off to a data lake for analysis and breakdown. The bottom line is we have a non-intrusive latency measurement coming through these very, very expensive tools that gives end users a view of how these farms are working and why at certain times of day they may be seeing more latency in their network than at other times. And again, all of this is possible because we have control of the silicon through P4, we have control of P4 through the NovaWare and NoviSpeaker, and we can focus on just the development side. And so things like the parser that lets us open these packets up, add new stuff, take it out, and right there in the NovaWare are so powerful that we were able to bring this into the marketplace. And this is really innovative. We don't see anybody that has done this before. But again, another proof point of how powerful these technologies are. And finally, we're going to give you a little sneak preview of something that we'll introduce a little bit later this quarter. This has to do with the taps to tools analytics that we see out there, where you have a number of taps or spans in your network. You're getting packets into you. You're going to send them to one or more tool sets that are very sophisticated in giving you vision into what's happening in your network, what types of packets, where you're getting attacked, all of those things. And we looked at it and said, there's a better way. There's a better way to do this. An algorithm inside that gives the end user more flexibility and more power. And we came up with a new algorithm. And this algorithm focuses around a 4-stage process that the users know what you're moving through. And then we gave them what we call agents, that you can configure these, and have them go to work for you. So you can define what happens at a specific, point in these sets, in these stages. For example, on the tool set stage, am I load balancing to a set of tools? Am I multicasting to a set of tools? And you craft that agent. And then the user organizes, builds the pipeline by organizing, putting those agents together, coding them together. Say, in this case, tap 1 is getting its feed from ingress 1. And that's completely in their control. They can set that up. They can change that pipeline tomorrow. They can change the filters, instantly, on that. So we're putting a tremendous amount of power in how do you map the feeds coming in from all these taps and spans into your, very critical analytics tools in a powerful way that will, summarize packets, filter packets, replicate packets, all of that stuff. And great. We think a great innovation. We've already had it in the field, knocked out the competitor of a very, very large company, and the customer just loves it. But the main point here, the testimonial here, is that from a blank sheet of paper to having the concept in a POC working in the field was less than 3 months. And the whole process from a blank sheet of paper to a commercial product is going to be less than 6 months. It will come out in the first half of this year, and it wasn't started at the beginning of this year. So again, another very, very tangible proof point of how powerful these processes are. So to summarize this, and hopefully we've given you a little insight to the types of algorithms that you guys could produce and the power and speed at which you could produce them. But to summarize the testimonials, that we fully believe in SDN as a concept, as a winning concept, it's alive and well out there to dynamically, and powerfully craft what your network looks like. The delivery of that through Tofino and P4 in a match action pipeline is sensational. Out there, we've believed in that for a long time and have a very successful product out there. That our NOS and our NoviSpeaker brings that capability to the application developer in an unparalleled form that's flexible and productive, and fast to market. I'm just, can't tell you how fast it is. I had a presentation a little earlier where I talked about on the POC side, we're consistently saying it's around an order of magnitude faster than we've ever been able to get anything into the field before. So big productive gains. And hopefully this little presentation has showed you that, the dogs will eat the dog food. We're not only make this stuff, but we're heavy users of it. So the NovaFlow applications show, how powerful it is and how competitive we can be, with this SDN technology in the marketplace. So again, thank you for your time. I've enjoyed doing this. Hopefully this added some knowledge and some fire about how powerful this technology can be. Thanks again. Bye-bye.